All right, this is a video going over on 2.3b, number 10 and 11, which talking about writing a formula for the area of a triangle in terms of time. And in number 10, you've got this point, you've got these points A and B that are staying exactly, not moving. So stagnant points. And then P is moving from B all the way around until it gets to A. So, and we want to figure out how to find the area at any point in time. And the nice thing is it's traveling around at 1 unit per second. So the distance and time are going to be the same, because remember, distance equals rate times time. But if the rate is always 1, distance is going to be time. Again, kind of nice. And so these first two here are the first two diagrams are depicting what's happening as the point goes from 1 second or 1 unit to 6 units. But remember, that's going to be the same as time. And the area there is always going to be 1/2 the base, and that base is changing. And the height is going to always be 4. So from 0 to 6 seconds, we can always do 1/2 times the base. The base is going to be time. So if it was at 2 units, the time is 2. Because remember, distance is rate times time, and the rate is 1, so distance will equal time. So for 2 seconds, it will be at 2. So 1/2 t, and the height is always 4. So that can simplify to 2t. But then things change after, at least in terms of the area formula, after 6 seconds, the area is going to be what we're looking at in this third figure. And no matter where the point is, it's always going to, notice it's always going to have a height of what? It's always going to have a height of 6. It's always going to have a base of 4. So it's going to have this constant area, which is 1/2 4 times 6. Or in other words, 12. So no matter what the time between 6 and 10 seconds, the area will always be 12. Okay, and then the last piece is actually not depicted here, so I'll draw it in. So this would be after 10 seconds, and then I guess it's ending here at 16. So 1, 2, 3, 4, 5, 6. So this would be 16. This is 10. And let's just draw in this triangle here. There we go. All right, so something like this. All right, so it looks pretty similar to the first piece, except remember, time keeps on going up. So this would be 11 seconds, 12, 13. Remember, time and distance are the same here. So I can't just say 1 and this whole length is 4. I can't just say 1/2 t times 4, because that would be, for example, if it was at 12, it'd be 1/2 12 times 4. And certainly this length here wouldn't be 12. But what would it be? It would be, how would I get 4? Because that's what it is. If it were at 12, I would have to do the total time, which is 16, and subtract the time that has passed, because that would give me the correct length. Again, this is when t and distance are 12. Okay, so that means the last piece is going to be 1/2, and then this base here will now be t. Total time, 16, minus the time has passed. If I did t minus 16, that would be a negative value, which we certainly don't want. We don't want -4, and times that height of 4. So that's the case for 10. Okay, let's look now, kind of adding adding a level of complexity in 11. This time, both points are moving. And they're moving at the same rate, and they're both moving at 1 unit per second. So again, distance, if it's rate times time, distance and time will be the same here because the rate is just 1. And notice, so it's going to be until I get to this corner here, which is 4 seconds, the area, I can find the area the same way. So the area is going to be 1/2. The base is going to be t. T and distance are the same. The height is also going to be t. So it's going to be 1/2 t squared until I get to 4 seconds. So that's that kind of first picture there. And then it'll be a new formula. So looking at the second picture, until, so this point Q has passed beyond 4, so it's going along here. But point P still is remaining along this like baseline here until I get to 6 seconds. So from 4 to 6 seconds, let's look at picture 2. And the area will be 1/2. The base is still continuing, so it'll still be t, but the height here is always going to be 4, and that simplifies to 2t. It's this last one when point Q is continuing along the top. However, the height now certainly is not always 4 because P has rounded the corner. So it'd be really challenging to find this height because, frankly, it's always going to be changing because P and Q are changing. So instead, it's way easier to deal with right triangles. And so dealing with finding the area of the entire rectangle and subtracting these 3 areas is easier. Okay, so let's think about these 3 areas. And before doing so, this is going to be from 6 seconds, and we're going to stop here when the points actually come together, which is going to be 10 seconds. Okay, so let's do each piece at a time. So let's look at this piece. All right, so again, remember, we're after 6 seconds, so 1/2. The base here, notice, as this point P is moving up to 10 seconds, it's always going to be, the base here is always going to be 6. But the height, like, so say it was at 8, that height is 2. So how can I think about that? I can think about it as, so say it was at 8, I can do time, 8 seconds, minus what has already passed here, minus the 6 seconds that were along the base. So that would get me that height there. Again, if it was at 9, it should be 3. So it would be the time was 9, and I'd subtract the 6 away that we already went on the previous case, the previous 2 cases, and that would get me that piece. Let's look at this one here. Let's do a similar idea. Again, B is staying the same, so 1/2. So the height here is not changing. The height is always 4. But in terms of, let's think if this point was at 8, then this base here would be 4. So I want to subtract out then this piece. I do time of 8 minus 4 to get that 4. All right, so that would be for that piece. And the last piece is the one that's a little bit trickier, because if we look at both this side and this side are going to be changing because both P and Q are moving. So we'll still say a half, but say we're at 8, both of them. Then I would take the end time of 10 and subtract out 8. So in other words, I'm going to subtract out the time for each side. So it would be 10 minus t squared. All right, and then, so again, as we said, to find the area of the red, it's going to be the area of the rectangle, which would just be 6 times 4, 24, minus the sum of all the different right triangle areas. So 1/2, 6, t minus 6 plus, running out of room, plus 1/2, 4, t minus 4, plus 1/2, 10 minus t squared. So I find it helpful, as you may have seen, to like pick a particular point in time or a distance and then think about, okay, what is the actual height or base, depending on what we're talking about, and how can I get that using the time? All right, hopefully that's helpful.